Hello and welcome back on another episode of Conversation on Artificial Intelligence. So Paolo is your host, and today with me we have Somnath Banerjee, who is the CTO of a very, very interesting company, LodgeIQ. Now, before we go into this, let me tell you this. If you are here for the first time, it is an honor and privilege to have you here. And if you're coming back, thank you so much. Why is this important and what we're going to learn today in this interview? We are going into a very interesting industry. We're going into the hotel and hospitality industry. And we're going to understand how the hotel and hospitality is going to forecast demand and how they basically manage their profits and costs using advanced analytics and predictive analytics and machine learning. So that's something that most of us do not know, but it affects our life, because when we go on holiday or we go on a business trip, the price that we're gonna pay, the availability of rooms that we're gonna find, it's all predicted and it's all governed by machine learning. And so today with Somnath, we're gonna learn how they do this. Hello, Somnath, how are you today?
I'm doing very good. Thank you, Paolo. Thank you for inviting me to your show.
Thank you so much for being here. Somnath, before we go on the machine learning and all the technology and so on, let's try to understand a little bit something about yourself. Let's say this, you live in Silicon Valley, you've been a technologist for many years, so you're pretty accomplished at this point, you're a CTO. But what if I give you a time machine and I just take you and I bring you to when you were 18 years old in your hometown and you had to talk to your friends with whom you were going out when you were 18 years old? What would you tell them about what you have been doing here in the United States all this time?
I would tell them, first of all, that's an awesome question. I would like to think, and I would like to tell them that I'm working very hard not to grow a second older than 18 years old. So in my heart, I'm still 18 years old. So I don't probably need the time machine. And I practice it by saying that every time there's a newer technology, I go out of my way to learn newer things. When iPhone first came out, it was a love affair to understand the iPhone SDK, how to program and how to build an app on iPhone.
I will have to pay attention not to let your wife knowing about this show then, because it could be problematic. Okay.
So I would like to tell when I go back to my childhood friends, I'm always interested in knowing the future. And one way of knowing the future is to try to learn newer technologies.
And so basically you're pretty enthusiastic about new technologies. So how long have you been actually working in the analytics, big data and machine learning field now?
So it's a very interesting journey, Paolo. I've been in the technology industry for almost 30 years now. I started my career at Texas Instruments Research Lab in Dallas. Back then, we were building AI software in TI labs in the late 80s. In the same labs where ICs were invented, but we were building AI software. Then I was in building VLSI design software. Then I moved to Silicon Valley. So throughout this journey, first, there was a chapter on the web when web applications came up, and we were all building web applications. Then we moved on to build Web 2.0 applications based on like building custom social networks. Then the mobile phones came and there was no looking back. There was an entire generation of building mobile applications and the entire ecosystem of mobile aware applications. Approximately 5 years back, I was exposed to machine learning, and it was like a love affair rekindled, because back when you were asking me when I was 18 years old, I was totally in love with math, but then the opportunistic me found programming, and programming was much more lucrative. So we kind of shelved math and went into programming because it was easier to make money and support a family and that kind of stuff. But when I saw machine learning, it was like a love affair rekindled, because it's an opportunity to go back to foundational math. And I'd say 3 kinds of math. Number 1 is calculus. Number 2 is linear algebra. And number 3 is statistics. So that love affair was rekindled because I can now take different mathematical models and put it in a computational structure. So I can combine almost the last 30 years of experience on something real. That's why machine learning was so interesting. So the journey started last 5 years. And again, I'd like to think of myself is going back to your 18-year-old question, that I'm a lifetime student. Whenever I find newer technologies, I try to learn them by taking the best of breed classes. And where do I find them? I find data science and AI and ML courses from Stanford in Coursera, or from University of Michigan, from UW, from Berkeley. So I have been constantly, I have been absorbing these courses, and that has rekindled my passion. So the machine learning journey started last 5 years back, and fountain of knowledge was these different Coursera courses.
So I think that's very interesting. I think for people outside of Silicon Valley, there are two big teachings here. The first one is really that, at least here, and I think that's another part of the world, but here is particularly remarkable. People and passionate people like Somnath himself, they follow technology waves. So they start their life, the career life, doing something, and then they eventually they evolve, and every 4 or 5 years they change. And so there is the concept of becoming obsolete in a way here. It doesn't apply too much because people keep using their brain as they progress. And then I think the second important teaching is that a lot of work goes into not becoming obsolete. So yes, we all went to the university some time ago, but the reality is you're going to, at least spend your 5-10 hours a week to, follow the novelties that's coming to the market. So Somnath, just to conclude on this, what type of effort do you dedicate in keeping you up to date? Because you have gone from firmware in the semiconductor industry to web, to mobile, to advanced analytics and machine learning and predictive analytics and machine learning algorithms. So that's a lot of learning.
Hopefully I have learned, not just captured all these things. But so one way of learning, there is the very sophisticated mathematical stuff. Then there is a group of people who try to put it in great libraries or frameworks. And then there is a third rung of people who try to utilize these libraries or frameworks like scikit-learn or Keras or TensorFlow. I would put myself like in almost like a third level. So the most brilliant minds are the people like in the classical thing. They're like the Eulers and the Gausses and people who come up with original math and principles. And then there's a second group of people who can take those things and build very interesting, sophisticated models which work. And those would be the people who would be coming up with things like the AlexNet, which was one of the first neural networks to recognize images from Jeff Hinton's lab. Or there would be the people like Visual Geometry Group, VGG, from University of Oxford from England. So those would be the second layer of people who will put this in a structure where this is available in a framework where people like me can use. So I would put myself with, hopefully I'm not overstepping or overreaching myself, but I'm happy to learn or stand on the shoulders of the giants and take a peek into the future. And almost like not only shoulders of giants, but people on top of their shoulders, but on top of them. So I'm actually kind of in the outermost ring of this knowledge, so to speak.
Yeah, but I think that has two teaching as well again here. One is, of course, that you can act and leverage a new technology by understanding which layer of it you have to put your efforts in. So that's an important teaching. I think at this point in time, we do not have like a lot of time to go back to school and getting the full understanding of every single detail. So we need to go and understand which piece will bring us to the point of really leveraging that technology.
So my motivation always has been a bit opportunistic, in the sense that how can I take modern technologies and wrapper it as a product which the end consumer or an end user can use. So I'm constantly in the hunt of going out on the web or the internet or different classes in top schools and try to find out what they're talking about, but how to wrap it as a product. So if I were to build an image recognition, where is the best? All right. They're a level above on top of these, but trying to take the angle of how to build a wrapper product which end users can use.
Yeah, so and I think that's what a lot of people here in Silicon Valley do is basically being able to, create product from technologies that are emerging, not necessarily, they are the creators of the original technology, but they know and they understand how to embed it into a product. And I also think that, the second teaching, I think, even if, you see your expertise in the third layer as those who apply the knowledge that's been already created, I think even that is still something that requires lots of, flexibility, mental flexibility, and willingness to move a step forward, because there are other industries and other careers where people keep doing the same thing for over 30 years, and it's the same operation. So that is certainly, like, the intellectual curiosity, I think, is another teaching for our viewers. You always have to keep, exploring new things. So with that said, let's look now into LodgeIQ. And I think given these very specific applications, also very interesting, very important for the industry, why don't, you try to give us kind of an overview of, how the industry works and how software is used and where is that LodgeIQ fits?
Sure. So this is actually a very practical day-to-day example of the previous question. How do you capture this knowledge and apply it in something practical? That has always been my approach. So about 3.5 years back, a private equity fund group out of New York who owns hundreds and hundreds of hotels, they approached me to form data science, AI, machine learning lab here in Silicon Valley to build a product which will make more money for the hotels. All right. I'm trying to simplify it so that all the viewers get it. Now, technically, this entire area is called revenue management. But essentially, we all have stayed in a hotel. Have we considered that how the price that we are paying for the hotel is being determined? Typically, there is a group of people, they are technically called the revenue managers, whose job is to constantly look at the revenue of the hotels, and then they're trying to make more money or optimize the revenue of the hotels by determining the price. And this is actually a very, very, very interesting problem. This has been there for quite some time. We are actually putting older wine in newer bottles. Let me elaborate what I mean to say. The foundational math has existed for quite some time. So let me break down the problem. There are two sub-problems here. When you're trying to determine the price, first you are trying to get a demand forecast. A demand forecast is how many people are going to come to your hotel. You want to know that 30 days early, 60 days early, 90 days, maybe a year early. You want to know how many people are going to arrive to your hotel and what kind of people. Are they a group of doctors who are attending a conference? Are they an IBM employee or a corporate customer? Or they are a retail or what they call a transient customer. So that segmentation of the forecast is critical. Now, you want to know that ahead of time. Now, in the hotel industry, what is very important is you use history as an indicator. History means what happened exactly the same day last year. And you also put in recent trends, like what is going on in the last several weeks in the recent past. And what we do is we use multi-texture data. Imagine like a concentric circle. So the innermost concentric circle is the data of your hotel, past history and forward-looking reservations. Right outside that concentric circle are the set of competitors that you have, the competitor hotels, because hotels are always looking at other competitors. And the outermost ring is the market. Market meaning the entire city or the entire big area. New York is a market, San Francisco is a market, Tokyo is a market, Rome is a market, like that. So essentially think in terms of concentric circles. Your hotel, your competitors, the market overall. So we collect data for that and put it in a big data stack. Now on top of that are exogenous data, things like flight patterns. Are more people flying into San Francisco or more people flying out? When they're flying in, how many passengers are staying for less than a week? If they're staying less than a week, most probably they're staying in a hotel. If they're staying for more than 2 weeks, they're staying with a relative. So the flight pattern, and most important, the shift in flight patterns are important. The other things are very critical are events. Is Beyonce coming to town for a musical show? Or if there is a Jewish holiday coming up in New York? These things, or there is a United Nations General Assembly happening in New York. These things are exogenous things which might impact the demand forecast. So we put all this data in a big data stack, and based on that, we use different models to predict the future, what is going to happen. Now, trust me, as soon as you predict the future, everybody becomes a skeptic. Everybody says, okay, show me. Now there comes much more intense work. What we have done is put in 80, 90, probably 95% of our work in building up highly automated machinery to not only predict, but also track our predictions. So as soon as tomorrow becomes yesterday, we get the actual values. So, and then we try to compare the predictions against the actualized things. It's almost like putting the weatherman to test. So today it is sunny, but what did the weatherman say 7 days earlier, 30 days earlier, 60 days earlier? So that is how we try to determine the accuracy of our prediction. We compare the actuals against the predicted, and then we divide it by different dimensions. A dimension could be day of the week. Are we accurate on Saturdays or are we accurate on Mondays? Are we accurate for the group customers or are accurate for the transient customers? How accurate are we away from the day of arrival? So there are many, many different dimensions where we can measure the accuracy and report that.
So who is for the audience that is more on the management side, who is the ultimate customer of this accuracy? Who requires that the accuracy is high and why?
Oh, the people. This software and this is needed by the people who are running the hotels or running chains of hotels. All right. So this is basically of highest interest to people at the topmost floor. You're not talking about hotel operational software. You're not talking about reservation systems. You're people who are managing the revenue, who are practically managing not only one hotel, but 10, sometimes hundreds of hotels. They want to know exactly what is the forecast. I mean, 2, 3 kinds of forecast. You want to know, number one, how many people are going to come, how much they're willing to pay, and what is the total number of revenue that you would make. So the forecast of the revenue is of interest to the highest level, the top floor people in the business.
I see, but the word accuracy, accuracy means many things. Accuracy, it can be within 0.01%, it could be 1%, it can be 10%, depending on business applications. Sometimes it's good to have 10% is perfect because you just want to know more or less. Some other times, like if you're flying an airplane, you probably have to be precise 0.01% because you don't want the airplane to fail. So how important is accuracy in this business?
It's a very, very good question, Paolo. I'm so glad that you're asking. So the accuracy, again, like before answering that question, so there are several sophisticated things that we use. One is, as I told you, to keep accuracy and keep us honest about our predictions and keep the models honest. We actually take time back and we play back these scenarios and play back these models and see how accurate we have. and we have built a labs infrastructure. The inspiration comes from the bigger financial industry. They use a term called back testing. So we frequently go back and run back testings out there in the cloud. And these are millions and millions of computations which happen in the cloud, because you can go back 1 year, 365 days, and for each one of these days, you make these forecasts, and then across these different dimensions, and we try to measure accuracy. Now, typically, if you can, the measure of accuracy will be different for different business users and the metric. So for demand, if we are within 2 to 5%, 30 days out, you are considered very, very good, very tight. All right. If revenue, if you are within 10%, you would be considered very, very good, because revenue is one level derived. All right. And revenue is also aggregated by different prices, the price which the consumer is ready to accept. So the goal at the end of the day, again, the inspiration comes from image recognition. 10 years back, only the recognizers could be only 70% accurate, then 75%, then 90%. Now the goal is to beat a human, all right? If a Stanford graduate student can shift through these different images in ImageNet, can recognize and make an error of 5%, if an automation can do it better, then they're considered very, very good. So the last time I checked, it was 3.5% or something. That is the state-of-the-art image recognizer models. So our goal similarly is, if you have a highly experienced human revenue manager, if we can beat his predictions, then we can say that our work is successful. But what is that exact cut line? It's hard to say, unlike the image recognizers. But I would say that for demand forecast, 2 to 5% within 30 days, good. 5 to 10% for revenue within 30 days, that's quite decent.
So just for, for the more business viewers and also for the engineers that are interested to build products, what type of business model does the company use to serve this service? Is it a software as a service? Is it on-premise? It's a licensing? What type of business model is used?
Good, very good question, Paolo. How do I actually put my hands on this, right? So again, I told you 4 A's. I like to talk about our things in terms of 4 A's. Our lowest A are the data and the analytics. That's the first A. We put in large chunks of data, put in a big data stack, and we analyze it. That's still pretty internal. Second are the algorithms. We can use all kinds of algorithms, from as simple as linear regression to random forest, to support vector machines, to tree ensemble models, to deep learning models. So all these algorithms to predict the future are, you can use different kinds of models, and then we do accuracy. The third layer is we package all these things as an API, as a REST JSON API, so that not only our internal applications can use them, but external people can also access them. So APIs are the third A. The fourth A are the applications. So we have 2 applications, one for enterprise grade, we call it Logic RM. The other is for more smaller limited service hotels, we call it Logic One. That's a simpler product. Both of these are available as cloud software, fully on the cloud, fully software as a service. So you sign up, you have a monthly payment or a yearly payment, and you can get access to our software where you can see these different things. You can see for demand forecasting, you can see pricing, and you can mix and match these different data sets to get a more accurate proxy for demand. Like you can get flights, etc. So to answer your question, it's fully software as a service available on the cloud.
So this software as a service, does it require data from the hotel chains as well? I imagine, like if you are serving the Hilton, for example, they have 5,000 hotels in the entire world. So they have their own data. So do you kind of mix the data that you acquire with the data that are on premise on the enterprise, or whatever service you provide, it's entirely provided on the basis of data that you source from other sources?
how many times you've heard that the data is the new fuel, data is the new oil, right? And data is what feeds the data science. So we can't do data science without the data. Now, more data you have, more accurate our predictions will be, and the better machine learning we can provide to you. Now, the data could be at an aggregate market data or this exogenous data like flights. But if you are ready to give us your data, then we can get to much accurate predictions. Typically, hotels which sign up with us have a connector so that they can upload their data to our servers, or have an API connect so that we can get their data. And sometimes it's as primitive as they are sending us a daily report, and based on that we process. So we have multiple channels of connecting with your hotel and acquiring the data. And then we cleanse the data, we normalize the data, we aggregate, de-anonymize the data, and put it in the stack. But our objective is with what we'd like to think is multi-textured, multi-level data. So as you have more and more precise data, our predictions will be more accurate. If you don't have the data, it will gracefully degrade with lesser data. And similarly, as time progresses, as you build up a body of data, your accuracy, our algorithms will also graduate to better and finer things. So data is very, very critical. So we like to put multi-texture data. Again, go back to my example of concentric circles.
So I have a very simple question then. If you, like take a customer that has all the data, okay? And so the best possible case scenario, how much more does an hotel make if they use your software and they optimize the price with your software, or if they go blind, like out of their gut feeling? What is the delta?
It's a very hard question for me. I don't want to kind of put a commitment. Now, let me explain. There is a technological side to this, and there is a business side to this. The technological side is, if you see the price elasticity curve, it will be a curve like this, and the revenue curve will be like this. And we want to pick the price where the revenue becomes maximum. So even if you pick the price and recommend that price, it depends on you, the revenue manager, to accept my recommendation and post it in your website. So first there is that thing, because there is always that human judgment. Even if the machine comes up with a $400 price, Paolo, you being the revenue manager saying that, that sounds too high. I'm not going to do that. I'm going to go 285. All right. So there is that degree of separation. The second thing, don't forget, even if I post that price, the end customer, the end consumer has to accept that price. That's where the consumer behavior comes in. And that depends on the advertisement, that depends on the particular situation. So there are multiple degrees of freedom. So it is hard to predict that, it is hard to put a pinpoint that with the best case scenario, you'll make this much more money. I can't do that. I wish I could do that, but those are the gaps.
So I understand, but if you had, let's take the question differently. How do you evaluate the impact that you have on these hotels? Like, how do you know that what you're doing is actually putting them in a better position than they would be if they were, if they were going blind? Because basically, to use an analogy, it's as if you're going them the radar, so they can see things ahead in let's say far. So you're giving them a radar. So how do you help them evaluating, like the impact, the positive impact of this technology?
Oh, that I feel very confident. There are at least 3 layers. Without these kind of tools, there are 3 layers. One is a very standardized BI tool where you can mix and match different kinds of data and get what-if experiments. That tells you what exactly has happened. Most people, most hotels, or most people in this travel industry, they do not have a single place where they can mix and match different kinds of data and to find out what exactly has happened, right? And that by itself is of a lot of value to a person who's making a price determination. The second thing is having this robot trying to go out and build a price, right? And recommend a price. That we don't, even though you take the classic case studies of machine learning, how many times human feel we are fine, we are making the right judgment. But a machine, since it can take so many different inputs and can process those things, it will actually, even though it seems counterintuitive to a human, it will make the right thing in the long run. So that is the second thing, is to predict the future and being able to pick the right price. The most important thing, Paolo, is something which we still haven't done and we are working on very hard, is to come up with mathematical ways to explain our predictions and explain our pricing recommendations. Area of interpretability is very, very critical. Again, the inspiration comes from deep learning and neural networks. Why does it recognize a cat? Because it has got pointy ears. Why does it recognize a dog? Because it has got snouty nose. So coming up with the explanation is to win the trust and the confidence of the end user. In this case, we can explain by saying that our pricing recommendation is this because competitor pricing is moving higher, or the market demand is tanking, that's why. Sometimes it's even counterintuitive. So coming up with explanations are very, very important. And again, I'll make a long story short. You are extremely technical, Paolo. You have been a scientist and researcher. It's a lot of partial derivatives. It's a multivariate curve, and you're trying to find the minimum of that curve, and the dimension which is giving the maximum of the partial derivative, that has the strongest influence here. So we can use techniques like that to explain which dimension is creating the maximum impact. But translating it in a business vocabulary, in a domain vocabulary, helps us win the trust and confidence. So AI sometimes, or most of the time, is not only artificial intelligence, but it's also augmented intelligence. We are dealing with people who have spent 5, 10, 15, 20 years in managing hotels. They are very sophisticated users. They know that I can create a sea of numbers of Excel, and within 2 minutes, they can say, December 17th, you are wrong, Somnath. They're that sophisticated. So I can have the machine and give them the augmentation. They will slowly get the trust and confidence. The machine will tell them what has happened, what is going to happen, and what they should do to correct the course, and finally give the mathematical explanations to justify that course correction.
So this is definitely not only very interesting, but I think it is also an important teaching for the audience. So you see, when we go into a B2B type of service, a service that is critical for the generation of revenue, this question and issue of interpretability of the algorithms comes out. And why is that? Because when the stakes are very high, in B2B especially, the algorithm alone is not sufficient. You also need ways to explain to decision makers why this prediction or this suggestion by the algorithm makes sense. Otherwise, the decision maker will not follow the algorithm. And so this is a topic that I am going to explore again in another interview and other videos. So for the time being, what I'd like to now introduce our audience to Somnath is basically predictive analytics has been there for quite some time. I think it's more than 10 years, it could be 15 years, or that people have started to predict demand and so on. What has changed and how things are better today that we have, let's say, access to more computation, more data, but particularly to algorithms have been generated in the last few years? What's better, and how is your system doing things that could not be done 4 or 5 years ago?
Very, very good question. I constantly think about that because going through my long journey through technology and these different things, what are we doing different? So 2 things come to mind. One is scale. Being able to capture this volume of data, terabytes of data, from different sources, creating a data pipeline where I can very quickly unleash and add a newer data at this scale and then shift through that. So what things like Hadoop has enabled us, taking very inexpensive computer and have a very large file system. On top of that, there are parallel SQL query engines like Presto, and large companies like Amazon are packaging it as services like Amazon Athena or Google Big Tables or what have you, where end business user like me can shift through terabytes of data within seconds, right? And that also I can do. I don't have to have military grade hardware. I can buy this as a service to solve a business problem. So I can rent it when I need it. Believe it or not, every morning my robots wake up, make bids for spot instances. We can have a separate conversation on spot instances. These are very high powered instances. So we can bid for those, acquire those spot instances, load the data, load our retrain our models every morning. And then we relinquish those instances, and the whole thing happens within a matter of 30 to 40 minutes. And this happens day in, day out, every morning, like running a mini stock market, right? This computation 5 years back would have been impossible. If it was impossible for a smaller organization like us, right? So I call this machine learning at scale and machine learning at cost. Those are the two different things. Yes, there was large volumes of data, but only you can do it if you are a Google or a Facebook or Amazon. But now a small startup with some innovation can go in and use these services in an intelligent way, in a very cautious way. And they don't have to lose their house, but still they can learn, run these very sophisticated models on very large amounts of data. And that also, you pick, choose, rent, run, and disappear.
So you see more the innovation being on the infrastructure, the ability to analyze this data, as opposed to, for example, in computer vision, lots of innovation helps on the algorithm themselves, on the fact that they invented the convolutional neural networks, and now they can, they can recognize or detect objects to an extent that was not possible before. You believe in your field the big innovation right now is on effectively do this prediction over a large amount of data.
That's one side. Large amount of data, large amount of computation, renting that infrastructure, not owning that infrastructure or paying big amounts of money, but renting that on an on-demand basis, in an elastic basis. So that's one side. The other big thing, which is actually a corollary to that, is being able to mix and match different algorithms. Because if you think hotel, it's one side is purely the numerical things, the number of reservations and forecasts. The other things is being able to do text analysis on the different reviews, like the TripAdvisor review or something else. All right, so that's natural language processing, etc. And then the third thing is like going through the news or the weather or other things, but also going through different kinds of images and stuff like that. So mixing and matching these different kinds of data sets, different kinds of models to create a better proxy for demand. Even though it's a corollary to the first item which I said, which is like the infrastructural improvement, but mixing and matching different kinds of data and more modern algorithms on those kinds of data, that is a differentiator, which wasn't possible, Paolo, until very recently. Again, it was possible within Google, but not for people like us.
So that's certainly a big teaching, I think, and the fact that there is this democratization of using both machine learning and data at scale, it basically paves a future where other startups can thrive, and so the data not only become monopoly of these large companies. But before we go, because we're approaching the end of our time, I want to look a little bit to the future, and there is one thing that just come to my mind. See, it seems that you sit on top of a lot of data, and you have found way to generate the demand. or to generate a prediction for demand or generate a prediction for the cost. And this, if you think of it, this is a form of, personal assistant for the revenue manager. Today, we live in the world of so-called personal assistant for the, the secretary that can organize your calendar, or you have other types of assistants such as the chatbot and so on. Do you envision the possibility that, you can build algorithms and applications that actually become kind of a personal assistant for the managers? They can give more than just demand forecast.
There are a lot of decisions which we business owners took just by a gut decision. And that's why we respected them. Maybe they have built up this wisdom over age. But right now, because of these things, many decision makings can be done by machines. And there are two things of this. Actually, there are multiple things, but two comes to my mind. One is the benefit of scale again, but it's a different kinds of scale. Let's say there are 1 million hotels in the world. How many can have a proper decision-driven revenue management? Only a few, only a fraction, maybe 10%, because only 10% can acquire this sophisticated software. But there is a possibility, or what the future presents is very sophisticated decision-making, very democratized and accessible, right? So just like you can have a personal assistant like Alexa, or you can ask Siri a bunch of questions, or Google Home a bunch of questions, and she will come back and respond with a very accurate answer. But the next stage is you give them a bunch of data, and they will be able to kind of shift through that data and give you the right decision. Should I take path A or path B? So those kind of things are coming in the next generation. So those data-driven decisions or algorithmic decision making are definitely on the roadmap. And I'll take a very simple example which will appeal to you, me, everyone, like an automated stock broker, a bot which will buy and sell stocks for us. Maybe it will not buy and sell, maybe at least I'm not that adventurous, but even if a bot went and shifted through all the data and told me, Somnath, you should, this morning, given your profile, given your portfolio, given your participation, you should buy this stock, or you should immediately sell this stock. Maybe I will not consider it, but at least there is somebody who's making that recommendation to me in an algorithmic way. And then if she can justify the decisions through explanations, that becomes even more hotter, doesn't it?
Definitely it is. And this is, there are a few startups are working in that in the finance area to give, recommendations. And how do you see this happening in your sector? Like a bot that recommends, so what else could be recommended to the manager?
Well, again, several decisions. What in our case, there are many decisions which can be made. Maybe you sell more in Expedia, or you sell more in Booking, or you advertise more in the European sector because most of your guests are coming from Europe and they are willing to pay more money, all right? So you advertise more on that area. So you target a certain segment. So, or you can put some length of stay restrictions. You can come from Europe, you can stay on Friday, but you have to stay through Sunday. So there are several decisions which are taken, right? And those decisions, if not completely automated, can at least be augmented via a machine. And I gave you the stock market example because all of us can connect with that. But there are gazillion other real life decision-oriented systems, which were for the last 3 decades, even with these computations, were done totally by humans. Yeah, the computers shifted through data, but they couldn't predict and come to some decision. Now we are coming to an age where these decisions are possible.
So all of this is very interesting. I would take you here for another couple of hours, but our time is actually over. So for the audience, what I like to say is that, as you see here, we have explored a B2B application, but it's very, very interesting because one, it's something that affects consumers at scale. So basically the price they're going to pay in the hotel. Two, is very important because it shows how these techniques of machine learning are having an impact in driving management and driving functions that before were completely based on the gut feeling of people. And three, it's also important because we are kind of at a point where probably these techniques of guiding a human being are going to be further expanded in the near future, and they will be connected with additional technology such as voice, such as the mobile phone, and so on, and will make the workflow of managers even more smooth and more assisted, if you like. And then finally, another thing that I would like to remark about this conversation is the huge importance of model explainability in the field of B2B. Because in business, there are crucial decisions that are being made. And if there are crucial decisions, managers have to know why the machine learning is coming up with a certain recommendation.
That's
so
correct.
With that said, I hope this is very interesting. Let me thank Somnath once more. So it was a pleasure having you here. And thank you so much.
You're welcome. And thank you, Paolo. It's your excitement which got me ignited. So I really enjoyed our conversation.
Thank you so much.